Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.
What's up, everybody? This is Earth is Life, and today I am going to explain, or I'm going to demonstrate, how a Selenelion eclipse works on the globe model. Of course, we all know that anytime you get into a conversation with a flat earther, especially when it comes to eclipses, they're always going to bring up the Selenelion eclipse and try and explain how it doesn't work on a globe model, which it does. It's just you just have to be in the right location, because what it does is it involves refraction, which they claim that refraction does different things than what it actually does, right? I guess they think that refraction can't lift things above the horizon, which is what it's doing during Jesus Christ, I still can't freaking say it. During a Selenelion eclipse, which happens either at sunrise or sunset, the refraction actually lifts the sun or the moon up above the horizon, so you can see both of them at the same time. But there's other things that have to happen also. You kind of have to be at a good height or a good elevation in order to be able to see it, because being at sea level, you're probably never going to see it. So what I'm going to do is I'm going to use Space Engine to kind of demonstrate how this works, because I recently had a conversation with a flat earther who challenged me to demonstrate it, so I'm going to do that now. And hopefully when I show this demonstration, he'll look at it and say, you know what, that actually does kind of work. But you and I both know that that's not going to happen. The demonstration is going to go right over their heads, and they're going to continue making the same claim as they normally do. So this is what we're going to do. For first thing we're going to do is, we know that Space Engine, the Earth is round. It's a globe. It is a to-scale model of our solar system. You can go to any planet you want. But for this demonstration, we're just going to use the Sun, Earth, and the Moon. Now I'm going to find the Moon. And this specific eclipse happened on 2018, January 31st, 2018. And if you want, you can look it up. You can look up the path of totality, and just in case you don't think this isn't a real eclipse and I just made this up. So what we're going to do is we're going to find the Moon. Let's go to the Moon. Okay, where's the Moon? Moon is right there. And in case you can't see it, I'll go ahead and zoom in. I'll go ahead and zoom in on the Moon. That way you flat earthers can see it. I'm not trying to play a trick on you. Yes, that is the Moon. There it is. All right, and then I'll zoom back out, and I'm gonna turn around, and there goes the Sun. Right. So now, this specific eclipse was visible from, I think there's a video out there by the debunker who did a pretty good video on this. That's how I knew about the location. So the location was the northern panhandle of Florida when it was visible. So I'm going to go here, and I'm going to go to the northern panhandle of Florida. I'm going to go down to the surface. Right about here somewhere. Okay, boom. So I'm on the surface of the Earth, and we're going to find the Sun. So the Sun is obviously over there. The Moon is right there. So right now, I am, hold on one second. The Moon. Right now, I am 1 meter above the surface of the Earth. I'm going to raise up just a little bit to try and get the Sun and the Moon above the surface. There we go. Okay, too far. There we go. Okay, so now let me turn around. There's the Sun. Okay, let's put that right about there. Now turn around. Where's the Moon at? There it is. Moon is right there. Let's zoom in. Boom. So you can see during this eclipse, and the eclipse is already happening. And just in case you don't think it's an eclipse, let me go ahead and hit the play button. Let me hit the reverse. You can see that as it reverses, the shadow starts to move across the surface of the Moon. So this is definitely during an eclipse. And I'll go back As you can see, it's dropping down, and the shadow is coming from the top as it sets. Exactly as they say can't happen on a globe. Boom. Let me zoom out. Let me go back a little. Let me go back a little bit. That way you can see, get the full effect. Zoom out, and let's see. Sun is still above the horizon. Moon is still above the horizon, and we see the shadow coming from the top down. Well, flat earthers, there you go. That's how it is demonstrated on a globe model. So now you should be able to concede and say, you know what, Earth is life, you were right. I was wrong. It works perfectly on a globe. But like I said before, they're going to see this and they're going to be like, nah, they're going to act like they've never seen it. That's normally what they do. Let me go through it again. Shadow is on the top. Shadow on the top, coming top down. Right? We zoom out. Let me zoom out. Above the surface of the Earth. Sun above the surface of the Earth. Just for context, let's see how high I am. How high above the Earth am I? Let me just drop down because I think I'm a little too high. There we go. Let me go right about. Let's see. I'm 800 meters. Like I said, you kind of have to be a significant height above the Earth. So I'm gonna let it play for just a tad. That way I can get the sun above the surface. Where's the moon at? Where are you? Where'd you go? Where's the moon? There it is. Right there. You probably can't see it. Let me just zoom in. Not, just so you know, I'm not trying to pull a fast one on you. There's the moon right there. Okay. I can't select it. There we go. There's the moon right there. And just for context, I am. Let's see. I am 700 meters above the surface of the Earth. Like I said, you kind of have to be at a high altitude in order to see some of these things. And the sun is just below the horizon. Let me just let it play for a little bit. Let me go back to where the moon is at. There it is, right there. Let me let it play just a little bit. Okay, you can kind of still see it right there. Yep, moon is still above the horizon right there. Zoom out, and the sun is right just peeking over. So like I said, if you get to a higher elevation, you can see this. You can see that it works just perfectly. You're never going to see this you're never ever going to see a Selenelion at the at sea level. I don't think. I could be wrong, but I don't think so. I might be wrong. Correct me if I'm wrong, anybody in the chat. If you find this video, let me know, hey, you're wrong, and I'll correct myself. I like being wrong. That way I know I like being wrong, because if I'm wrong, I find the right answer, and then I'm right again. Boom. So, let me see if I can find it again. Where's the moon at? Moon, okay, there it is. Up, see? Still above the horizon. Okay, let me go back. Let me go back down. Where is it? No, where's the moon? Come on. Well, either way, I'm still above the surface. Moon is above the surface. I'm probably only 700 or 800 meters above the surface of the Earth, and as you can see, both are visible, and the shadow is coming from the top. So, there's your demonstration, flat earthers. If you don't like it, hey, that's on you. But you and I both know that there's absolutely no way that you could ever show this on a flat Earth, ever, because the Earth isn't flat. Anyway, once again, thanks for watching. Don't forget to like, share, and subscribe if you like this video, and check out the rest of my videos if you're interested. And as always, peace.
Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.